Good. Here. Let's put it like here. Okay, good. So I want to tell you about an alternative arc process. This is called oh gosh, flash welding. Flash welding. And in flash welding, what we do is imagine you have two rods, and you, in this case, is as if the two pieces were the electrode. So you run the arc, jumping from one piece, from one rod to the other, and the local heating will melt them, and then you press them. And when you press them, it squeezes out all the molten much of the molten metal, and gives you a weld in which all the impurities have been expelled, right? And whatever is kind of ugly looking on the side, that's what the flash sticking out, that typically is machined. So in this case of flash welding or flash butt welding, right, we typically don't have a protection for the melt. And this is because we melt the metal, and there will be oxidation, and there will be nitrogen also coming in. But when we press then the two parts together, we squeeze that out, and what is left is quite high quality. Of course, if you're going to do something like this with titanium, you need to put shielding, because titanium is extremely sensitive to oxygen. In some cases, you can use a reducing flame that would be like sucking up oxygen away. Filler material, in this case, you don't have filler material. And the polarity is typically AC, although in some cases I heard of this flash welding done in DC, in which one electrode would be positive and one would be negative. And in this case, if you remember, we talked how some processes don't typically, fusion welding doesn't need pressure. One exception was resistant spot welding, making cars. And here's another exception in which you put pressure to squeeze out the molten metal with impurities. This is automated, right? You don't do this by hand. Typically, it doesn't require a joint preparation, because you just are going to squirt out everything you melted, right? And it says it can weld the similar materials, but there is an asterisk there, right? No, fusion welding is not so easy for the similar materials. Applications can be on the shop or can be on the outside. Some things in which flash welding is used. Railroad tracks, they're often welded using this process. There are other ways of welding railroad tracks too, but this is one of those. One of my students, when I was in Colorado, is involved in the welding of railroad tracks using flash welding. This is especially important for high-speed trains. Bandsaw blades, have you ever wondered why the bandsaw that doesn't have like a joint that skip? All right, those are flash welded typically, just like using this process I mentioned here. Metal construction, aluminum to steel to copper bars, but these need electrical conductivity, but they are seldom subject to structural demands, right? And one very, very interesting similar process is stud welding. So when you're welding a deck in when you're welding a deck, you would have the circuit between the deck of a bridge I'm talking about. Before you put the concrete and the asphalt over the steel, you put all these studs. So the concrete grabs to the steel. And yeah, like Wes mentioned here, the stud is connected to one of the leads, the plate is connected to the other. You put this ceramic sleeve that protects the area of the arc. And then you do the arc for a little while to melt a little bit of stud, a little bit of plate, and then you go in, and as you press, it ends up being welded. And this is very quick. You have special guns for doing this. We have one of those in the lab, but we have never put it to use in 10 years. So if anybody is interested in resuscitating old equipment, that can be a fun thing to try whenever we reopen the lab. So this is about arc welding. Now we don't need to worry about this, but you have all those true false in all the exams. And what I'm going to do is